Hello CS112. Today I'll be doing a quick solution of Lab 1, which had to do with user input and Python basics. So for this walkthrough, I will be doing it in Visual Studio Code, which is what I used and I would recommend using in CS112 as your text editor. So it looks something like this when you first open it up. What you would want to do is first actually open a file to start coding on. So I'm just going to say new text file, and as you guys should know by now, I'm going to immediately go to save as. I'm going to name it anything .py, and then I'm going to make sure I save it into a folder that I'm going to remember. So I'm going to save it into my UTA folder here. This .py is all you need to do to cast it to be a Python file. You do not need to go through here. In fact, if you go through here and select Python in here, it will become dog.py.py. So just do the py. It's a lot easier than going through this list. Click save, and now you have a Python file here. So now the first thing I'm going to do is I'm going to paste kind of the description that we had for this lab. And you were essentially to calculate a simple Python program that receives frequency as the input and calculates the wireless signal transmission as the output. So as you can see here, this is the what you would be doing with your Python code. They gave us some separate information as well. So they gave us what GT, GR, PT, and R equals. It also told us several other things like that L is going to equal 3 times 8 to the 10th, which is equivalent to, they showed us how to do scientific notation in Python as well. And they also gave us several example runs actually that we could test our code with, but ours right here is just going to, ask the user to enter the frequency. So this would be displayed in the terminal right here. This would be displayed in the terminal. You would type 2.45 in the terminal, and then it would output the received power is, and then the received power you got. But it should also say watt at the end. So let's just dive right into this. The very first thing we are going to want to do is actually ask the user for the frequency, right? I think that's what we're doing. Yes. So as you can see here, it says in the example run, we should always copy exactly what it's expecting. So I'm just going to actually copy that. And then I'm going to say create a new variable called frec. That's going to set that equal to a float input. And inside the input parentheses here, that is where my argument goes. My argument is just going to be the message that is displayed in the terminal. Now, if you want that extra space in the terminal to show up where you're typing in the user will type, you just put a space at the end there. And if we wanted to test this out, because we're pragmatic programmers, I could just print out my frequency after maybe have a little message in there as well. Say like frec is, and then the frequency. If we wanted to test this out, and this is one of the main reasons I recommend Visual Studio Code, is they have a built-in terminal within the IDE. Within the text editor. So you don't need to open up your terminal or command prompt. It has a built-in terminal here, and it can have. I have mine automatically set to GitBash, which is Unix based, but you can also have the command prompt if you're a Windows user. So the first thing I'm going to do is I'm actually going to go to this path. So first I need to go to my OneDrive, if I can type, school, and then UTA. And if I was to just list everything out, you can see that dog.py is in here. So now I can start working with this file. So if I was to type in py space and then dog.py, as you can see here, it's going to say enter the frequency in gigahertz. And let's just say 2.45 for the example we're working with. And as you can see, I'm correctly gathering the inputs and storing it in the variable frequency. So again, I would like to mention that for my computer it is py, but yours might be Python or Python 3 to run a Python file. Okay, and as you can see, this space right here allowed me to have a space when typing here. So for instance, if I was to just remove this space real quick, save the file and run it, I would now be typing right next to the input, and it's not as clear as something like this. So I mean, it's up to you. It's up to you, but so it's good to make it more readable. So now that we have gotten our frequency, we now need to start with the calculations. So what is the first thing we want to do? Well, we do want to actually get our, the first thing I'm going to do specifically is calculate lambda, because that lambda is part of our final equation here, and we have the equation for lambda being 3 times 8 to the 10 divided by the frequency input we just got. So I'm going to actually just copy this right here. Well, first we should be commenting our code. I'm going to say like get frequency from user inputs, and the next step is going to be to calculate lambda. And I'm also going to, up here, include the lambda. I'm just going to keep that part. The lambda formula that we were given there, just so it's easier. So I'm going to create a new variable. So I cannot use, a lot of people were using this and getting syntax errors saying lambda equals and that. As you can see, the color is already changed. This is a keyword in Python, so it cannot be used as a variable name. I'm just going to say lam. So lam equals, as we're literally given the code for this, 3e8 divided by the frequency we got from the user. Now again, you needed to wrap this as a float so we could do math with it. If we didn't, if we just had the input statement on its own, it will be implicitly a string. So instead of having a number 2.45, I think it was, to work with and do math, you would have a string 2.45, which you cannot do math with. So that's why we are casting it to a float as soon as we get it as a string input. So now the very next thing I'm going to do is I'm just going to go ahead and, because we know that lambda is squared in our formula, I'm just going to go ahead and square it. I'm just going to go ahead and say lam equals lam, I can say times lam. Since we know we're not working with lam ever again, I'm just going to go ahead and just square it. Or yeah, so just so you guys know, this is the same thing as saying lam times equals lam. So I'm actually just going to leave it like this. So now that we have that, we can start with some more, actually getting the actual answer. The answer is, I'm just gonna create a variable. Let's start here saying calculates final, what is it called? Input, calculate the wireless signal transmission. So calculate final wireless signal transmission. Okay, so here I'm going to, this is actually similar to what you guys are programming this week, where it's very math-based or math-heavy. I'm going to break up all of these into specific steps. One of the first things I'm going to do is I'm actually going to bring down all of these guys as variables, just so I have them nice, neat, and consistent. Then I'm going to actually bring down this entire formula and leave it as a comment, so I don't have to keep scrolling back and forth. So I'm going to add this as a second line comment here, just so I know what I'm working with here. And I'm going to say PR is going to be what I will have my final answer variable be. But like I said, I do want to break these up into as many steps as I can. So I'm actually going to first calculate the numerator, and then I'm going to calculate the denominator, and then I'm going to actually divide these two separately into that final PR variable. So I'm going to create a numerator and set that equal to PT, which we already have as a variable right here, times GT, which we have a variable right here, times GR, which again we have as a variable, times our lambda squared. But we've already squared our lambda here, so I can just say lam. And for our denominator, I'm going to set that equal to, what is R? R is 100. Okay. So I'm going to set that equal to, what is that? 4 times pi, 3.14 in this case, times R. And this is squared. So I'm going to split that up onto 2 lines. What happened? I'm going to split this up onto 2 lines just to be safe, because, we always want to be safe. I don't know what's happening right now. Because we always want to be safe. So I'm going to say denom equals, or times equals denom. which is the same thing as saying denom equals denom times denom. So now that we have both our numerator and our denominator created, I can create that PR variable. So PR is going to be our wireless signal transmission in watts, and I'm going to say that that is going to be my numerator divided by my denominator. And now display return message. So now that I have gotten my PR, now we want to show the user what their frequency is. So we want to display a message that looks like this. I'm just going to temporarily keep this line here just so I don't have to keep going back and forth. But I'm going to say print the received power is, and then it wants a space between here. So there are multiple ways you can add a space between here. I'm going to go ahead and just do a comma there. And then I'm going to be using my PR variable right here, because PR is what we calculated. And then another space followed by the word watt. Now, if I was to save this, and let's test it out with this first input. Well, I do want to get rid of this line because that is not valid Python syntax, but I'm just going to hit save. So I'm going to look at this specific example here. I'm not going to run through all the tests for the sake of time, but let's just check if this works. So again, I have saved my file, so I'm just going to type in py and then the name of the Python file. I'm going to click enter. It's asking me for the frequency in gigahertz. I'm going to say 2.45, and it should give me this number here, which it does. It does match this number up here. I got the correct answer. Just for the sake of showing you guys some string formatting, because this is going to be very relevant to your future projects. What if for some weird reason you didn't want spaces between your numerical value here? Well, you can't. You would think that the right thing to do is to use string concatenation, right? So to just squish these together. Well, if we were to run this, so let's just try it again with these same inputs. So 2.45, you would get an error because right now you're trying to add like the word watts with the number 2.45. That makes no sense. So what you can do, however, is first cast this to a string, hit save, and then you should get the proper answer again without these ugly, with no spaces. If you wanted to keep this as a string and add more spaces, you can just pad the white space here, right? And you should get the original answer we had, so 2.45, and we get those nice clean spaces again. So it's nice to play around with the three ways that I showed you how to format a numerical variable within a print statement and a string. It's good to get comfortable with that because a lot of the future programming assignments will have to do with specifically formatting a string without the very powerful F strings, just a regular thing like this. So it's good to know about these. Padding these white spaces here, maybe even playing around with some of these tokenators, seeing what those do, and as well as seeing what the plus does versus the comma in a print statement. So if you have any questions, do let us know.